Hi, everybody. I hope that you are safe and that you are well and that things are going great. I'm here to talk about some introduction to graphing inequalities. So, you've been graphing equations, right? And equations have equal signs. So, you've been seeing things like y equals 1/2 x plus 5. Or you've been seeing things like y minus 2 equals 3 parentheses x minus 4, right? Or you've been seeing in standard form, you've been seeing 3x plus 4y equals 6. These were all equations because they had the equal signs, okay? These were equations because they all had the equals signs in them. Now in this video, we're moving on to inequalities. And inequalities are going to work just the same, right? We're going to have inequalities that look like y is greater than 1/2 x plus 5, right? It has an inequality symbol here instead of an equal sign. Or you might have a different inequality symbol in an equation or an inequality like this. Y minus 2 is less than equal to 3 parentheses x minus 4. Or you might even have a standard form one where it's 7x plus 6y equals 10. Oops, would it be an equals? We're talking inequalities. Maybe greater than equal to, right? So all three of these have inequality symbols. So that's what we're going to work on graphing next. You've become an expert at equations. Now you're going to become an expert at inequalities. And I just want to make sure that we know our four inequalities and what they look like and what the names are. So I'm going to write them out here in this black. And I guess it would help if I put on my glasses, right, so I could see better and write much nicer. So in this black, let's just go over our inequalities and make sure we have those vocabulary words down. So we have some inequalities that look like this. And they are opening up to the left there. These that are opening up to the left are greater than. This one is a greater than. This one is also a greater than because it's also opening up to the left, so it's still a greater than. But that little line underneath makes a difference, and we're really going to learn about that difference. But this inequality with that line is called greater than or equal to. And you're going to see why pretty close to the end of this video. My goal is by the end of the video, you will understand exactly why some of them have the line and some of them don't. Why some of them are equal to and some of them aren't, right? So we have greater than, equal to. Then we have two more. I guess you can probably figure out what they are, right? They are flipped around the other direction. They open up to the left. And I guess you could probably think the name of these, right? If we have greater than, this one is less than. If I were you, you might want to take some notes on these vocabulary words here. You're going to be using them throughout this video and throughout your practice today. This one is a less than, and just like the one above it, less than or equal, that's an E-Q-U-A-L, equal to, because it has that special line underneath. And we're going to talk about what those lines mean and why it's equal to and what the heck equal to means, okay? So a little trick that I learned back when I was in middle school is that if you hold up your left hand, and remember our lefts might be different because this camera flips me around. So if you hold up your left hand in front of you, I'm going to hold up mine. So hold up your left hand in front of you and squish that down just a little bit like this. That's the less than symbol. So you can never get confused which way it goes, okay? Left hand, less than, that's what the symbol looks like, okay? So don't get those confused. That's our four vocabulary that we need. So let's jump right into this introduction of our inequalities, okay? So our first one here, I'm going to start with what we know, okay? I'm starting with an equation because this is what we're an expert at right now. So let's start with that. Y equals 4x minus 2. What form is that in? I see that it has y equals mx plus b, and I know that the m is a slope and a b is a y-intercept, so this form is called slope-intercept form. That's what form this is in. Again, just bringing back those vocabulary words, right? We want to continue to remember those names and practice them. So here in this equation, it's an equation, it has an equal sign, right? We can note that also. This is an equation because it has an equal sign. Let's look at this information. In this, do we know what our m is? Our slope, what is our m? It's 4. And remember, our slope tells us how much that we rise over how much we run. So really, what can I put 4 over to know how much I'm running? What's that imaginary number we're putting there? A 1. Y'all are experts at equations. Absolutely, my slope is 4 over 1. My b, my beginning point, or my y-intercept, look carefully here, is a -2. So now that we know these two things, we're going to use our b to begin. So I'm going to begin at -2 on this y-axis. So I have to go to 0, and I'm going to go down to -2 there. That's the point where I am beginning. That's my b. I'm going to use my slope, my m, to move. I'm going to rise 4 and run 1. So rise 4, starting at this point, 1, 2, 3, 4, and I'm going to run 1 to the right because this is a positive slope. So 1 to the right, and I'm going to make my dot. I'm going to continue with that pattern. Rise 4, 1, 2, 3, 4, run 1 to the right. Rise 4, 2, 3, 4, 1 to the right. And then we know, because we are experts at this, that it doesn't just extend in this direction, but there's also points going this direction. So I want to fill in that pattern and make sure that I know these points down here exist. So instead of going up 4, I'm going to go down 4, 3, 4, and to the left 1 and make a point there. So I can go the opposite direction also. Down 4, to the left 1, and make my last point there, because then I'm going off the grid. Okay, I am going to connect these because we learned that equal signs, right? We can connect all of these points with a straight line. Trying to make it as straight as I can. There we go. Our equation is graphed. You are done. But now I want to explain to you why this works and why equations work the way they do, because this will help you understand inequalities in just a second. So this equation works, an equal sign. If I take any point on this line, right? I don't have to start with the beginning, but if I take any point, like if I take this point right here, that point right there that I circled in green, that point is at, let me count, it's at 1, 2, comma, 1, 2, 3, 4, 5, 6. It's at 2, comma, 6. And remember, in that point, in that coordinate, you have an x and you have a y. So here is the awesome, cool part, and it's all about to like blow your mind. You ready? So if I take this original equation here, so my original equation is, I'm going to write it over here, it is y equals 4x minus 2. That's the original. I now have an x and a y. Let's see what happens when I substitute that x and that y into that equation. So my y in that point was 6 equals 4. My x is 2 minus 2. And let's simplify this. So 6 equals, let's simplify this side right here. So when we simplify, we do the multiplication. So 4 times 2, do that calculation. 4 times 2 is 8. Minus 2, 8 minus 2 is 6. Look at that. Does 6 equal 6? It does. 6 equals 6. So that's a good point. It's on the line. So that makes sense. It's on the line and it works in the equation when I substitute those values. Let's pick another point just to make sure that this rule that we just found does work for every point. I'm going to pick one way down here in the negatives so we can make sure. This point right here that I'm circling in pink, let's see where that point's at. It's at -1, comma, then we have to go down, 1, 2, 3, 4, 5, 6. I went down, so I know it's at -6. This is the x, this is the y. Again, let's take that original equation. So y equals 4x minus 2. And let's substitute that x and y from the pink. That y is a -6 equals 4. That x is a -1 minus 2. We're going to do the same thing. We're going to simplify this side. We have to be careful when we do this multiplication because there's a negative in there. So 4 times -1 gives me -4. So I'm at this part now, -4 when I multiply those. Still have -2, so let's do that. Let's simplify that. -4 minus 2. If you think about a number line, guys, if you are at -4, here's -3, -4, -5, -6. If you are already at -4 and you're going to subtract 2 more, you're going even more negative, you're going even more negative. Subtract 2 more, it puts you at -6. So look at that. Does -6 equal -6? It does equal each other. So that is another good point. And it's on the line. That's how equations work. Any point on that line, you could substitute in and you could get a perfect equal to answer. So just to prove my point, right, that it's any point on the line, let's do this. Let's do some crazy point that's right here. Is that point on the line? Definitely not. So let's do that blue point right there. That blue point is at -1, -2, 1, 2. So -2, +2, an x and a y. I'm going to take the original equation, y equals 4x minus 2. And I'm going to substitute in that x and y from that blue point. So the y there was 2 equals 4. The x was -2 minus 2. And let's simplify this again. 4 times -2 is -8. And I still have that -2, so I'm going to bring it down. -8 minus 2. Remember, just like up here, if I was at -8 and I subtract 2 more, I'm going to be at -10. Now look at that. Does 2 equal -10? No, that doesn't equal each other. So this one is not a good point. And that makes total sense because it is not on the line. It does not satisfy that equation, right? When I plug in the x and the y, it does not equal each other. Pretty cool stuff. So equations are only points on the line here. The only points that work are the ones on the line. Let's keep that in mind. Let's put that like in a sticky note in our brain. Equations are only the points on the line. The points outside do not work. Okay, now let's go ahead and clear this, and we are going to do an inequality for our next one, right? We haven't graphed inequalities yet, so let's make sure we know how this works, okay? If you look at this inequality, it looks like y equals mx plus b, but there's not an equal sign. There's this symbol, and remember, if you remember back to that vocabulary words on that first slide, that symbol looks like this. That's my left hand. So I know it's a less than symbol. So it's a less than or equal to. Okay, I'm going to write that over to the side. This one, oops, this symbol is a less than or equal to. And that will make sense in just a minute. We're going to come back to this at the end of graphing. So since it looks like y equals mx plus b, we're going to graph it the exact same way. What's the m in this inequality? It's a 5. And remember, the m is my slope, so rise over run. In this case, we would be running 1 because I can put 1 underneath any number. My beginning point here would be a +3. So now let's graph it, just like we were doing equations, right? Nothing changes there. I'm going to begin at 3. So 1, 2, 3, and make my dot. I am going to rise 5 and run 1 to the right because it's positive. So rise 5. 1, 2, 3, 4, 5, and run 1 to the right. Oops, I don't think I can go anymore because then I'll be off the graph. So I'm going to go the opposite direction down here. Down 5, 1, 2, 3, 4, 5, to the left 1. And then one more time, I think I can squeeze on this graph down 5. 1, 2, 3, 4, 5 to the left 1. That's all I can fit on this graph. So I'm going to connect these dots with my line as straight as I can get it. There is our line. So now let's see what happens with this. I'm going to do a couple of test points here, just like we did in the other one. I'm going to test this point here first because it is on our line. We're going to see how inequalities work. So let's test this point. That point is at 1, comma, and I'm going to go up so it's positive. 1, 2, 3, 4, 5, 6, 7, 8. 1, comma, 8. And I know that that's the x and that's the y. Okay, we're going to do the exact same thing, except for it's not an original equation, it's an original inequality. So we're going to write y is less than equal to 5x plus 3. And we're going to substitute just like we did for equations. So y in this case was 8, less than equal to 5, my x is 1, plus 3. So again, let's simplify this side right here. 8 less than equal to 5 times 1 is 5, plus 3 is 8. Now let's talk about, is this statement true? 8 is less than or equal to 8. Yes, this statement is correct because it has the equal to line underneath. 8 is less than or equal to 8. That's true, right? It's or equal to makes it true. Again, if you were to do any other point that's on this line, it would also be true because it is on the line. Now let's do a different test point here. Let's see what happens when we do a test point here, not on the line. So make your prediction now. Do you think that this point right here in orange is going to make that inequality true? Do you think it's going to be a true statement, or do you think it's not going to be true like the equations? Make that prediction. Now that you have it, let's go ahead and prove it, and let's see if we were right or if we were wrong. This orange point is at 1, 2, 3, comma, 1, 2, 3. At 3, 3, perfect. So this is my x, this is the y. I'm going to take that original inequality, 5x plus 3, and I am going to substitute these values in. So my y was 3, less than equal to 5, my x was 3, plus 3. Let's simplify it. Simplify this side right here, right? 5 times 3 is 15, plus 3 more is 18. Now, let's read this statement and see if it's true. 3 is less than or equal to 15. Is that true? Is 3 less than or equal to 18? Yes, that is absolutely true. 3 is less than 18. So that is absolutely true. Did you guess that? Was that your prediction? So what this means is that inequalities also have points outside of that line that make it true. So I want you to notice something, that orange point was on the right side of the line here, right? If I drew a line, this would be the right-hand side. I'm going to take a test point from the left-hand side of the line over here, somewhere way over here. It could be any point. Let's just use this one, this green point. Do you think this point will make it true? Let's see what happens. This green point is at -1, -2, -3, -4, comma, 1, 2. So there's the x, there's the y. Let's substitute into that original. Y is less than equal to 5x plus 3. And so y was 2 less than equal to 5. The x is negative 4 plus 3. Let's simplify this one. Simplify this side right here. We gotta do some math there with a negative. So 5 times negative 4 is negative 20. Now I'm going to add 3. So if I'm at negative 20 on a number line, picture that number line. If you are all the way over here at negative 20, you're going to add 3. So you are going from negative 20, you're adding, so you're going this direction. So what would that number be? Negative 17. So now let's read this statement. 2 is less than or equal to negative 17. Is that true? Is 2 less than negative 17? Would you rather have $2 or negative $17? 2 is actually greater than negative 17. So that does not make any sense. This statement is not true. So what happens is when you have this inequality, any point that you do over here on this side where we did the orange point is going to make it true. Any point on the line is going to make it true. But any point over here will not make it true. So we're going to have some rules that we do with inequalities. I'm going to write one of those rules over here to the side. If you have a less than symbol or a less than equal to symbol, you will shade below. Meaning that if this was your line, if you go to your beginning and you draw a line down, all of this side you should shade. My shading is bad. All of this side you should shade in. Meaning that all of the stuff that you colored in are good points, right? That orange one was a good point. It was on this side. So if you have a less than or less than equal to, you shade below, meaning that all of these would be good points. You don't shade this side because remember, this one did not make it true. This is not a good point. And I do want to say one more thing. If you have a greater than or greater than equal to, do you think you're going to still shade below? I don't think so. That greater than symbol means that you will shade above. So you will start to learn these rules in the next couple of videos, and as we practice, you won't have to make test points every single time. You will just learn these rules and say, hey, if it's this symbol, that means I'm going to shade below, so all those points are good, right? You won't have to make all these test points and substitute all these values. This is just explaining why these rules work, okay? So less than symbols, shade below. Greater than symbols, shade above, okay? And there's 2 more rules. So that was our first 2 rules for inequalities. There's 2 more rules, and we're going to talk about them on the next slide, okay? So we're going to do one more example together. I'm going to go ahead and switch our slide for us. Here we go. There it is. All right, so here it is, our last slide that we're doing together in this video. It looks like another inequality, and it is also y is greater than mx plus b. So it's still in that slope-intercept form, right? My m and my b. But I do want you to take note of this inequality sign. So those rules that we just talked about, remember if it's a less than or less than equal to, which way do we shade? If it's less than, we shade below. Thank you for taking those notes, right? Some of you were taking notes over this. It's going to help you. We're going to shade below. If it was a greater than or greater than equal to, we will shade above. So let's look at this symbol real quick. This symbol right here is a greater than symbol. Greater than symbol. So just by knowing these first 2 rules, you already know that since it is greater than on this one, you are going to have to shade above. Without even making those test points, you know that the ones above the line are going to be the points that work. The ones below the line are not going to work. So let's keep going and see what else is different here. We're going to write out our M here is 2, but we know it can be 2 over 1 because that's our rise over our run. Our B is a positive 3, and that's our beginning point. So I'm going to go ahead and quickly graph this, right? We're experts at graphing now. So I'm going to begin at positive 3. 1, 2, 3. Make my first beginning point. I'm going to use my slope to move. I'm going to rise 2 and run 1 to the right because it's positive. Rise 2, 1 to the right. Rise 2, 1 to the right. Then I'm going to go the opposite directions. That way I know that the points extend down here. Down 2, left 1. Down 2, left 1. Continue that pattern to keep going as many points that I can get on this graph. There we go. And I am going to connect them. There we go. A little bit off. That's okay. I connected those dots. Okay, so you automatically know, since we knew that rule already, right? We're learning these rules so we don't have to do all of those different test points. Since this is a greater than symbol, we're going to shade above. I'm going to do a different color so that way you can see me shade. We're going to shade above. So if I go to my beginning point and I draw an arrow up, that means that all this side above is going to be shaded. So no matter what point you pick in this yellow area, it will work out, right? It will make the statement true, no matter what point you pick, okay? Points over here in the not shaded part will not make that statement true. But remember those points on the line did on the last one. So we're going to just do 3 test points because we're learning these rules. We're making sure that we understand these rules. I'm going to do a test point way up here, right? Proving that any point you pick in the yellow will work. So let's look at this blue point and let's count where it is. We're going to count carefully because I already shaded. That blue point is at -1, -2, -3, -4, -5, -6, -7, -8, comma, and I'm going up, so the next number is going to be positive. 1, 2, 3, 4, 5, 6, 7. -8, 7. I know that's the X, that's the Y. I'm going to take that original inequality. Y is greater than 2x plus 3. I'm going to substitute. My Y here was 7 to the X is -8 plus 3. And I'm going to simplify this side right here. 2 times -8 is -16. Now, -16 plus 3. So if you're all the way at -16, you add 3. That puts you at -13. So let's look at this statement and read it out loud. Let's see if it makes sense. 7 is greater than -13. Is that true? 7 is greater than -13? Yeah, I'd rather have $7 than -13. This statement is true. Again, that rule works, right? We knew it was already going to work because it was in the shaded. Greater than means shade above, so we knew that point was going to work. Okay, just proving that rule one more time. Let's look at a pink point down here. Again, is this pink point going to work? It's not going to work, right? Because in the rule, we shaded above. It's in the non-shaded, so it's not going to work. Just to prove it, right? We're in this video. We're learning together. Let's make sure. 1, 2, 3, 4, 5, comma, 1, 2, 3, 4. So the X, the Y. So my original is Y is greater than 2X plus 3. And I'm going to substitute. 4 is greater than 2 times 5 plus 3. And let's simplify and see what happens. 4, 2 times 5 is 10, plus 3 is 13. We're going to read this statement out loud. 4 is greater than 13? No, never. Never 4 is greater than 13, right? So no, this test point didn't work. We knew that because it's not in the shaded part. So here is the catch. This is, if you didn't get anything out of this video, let's listen to this last part because it's so different, right? Thank you to those who watched until this point because you're going to be the ones who get it. Okay, let's do a test point on this line, like this point right here, that one in green. Remember on that last one that we did, the ones on the equal sign worked on the line. The last one worked on the line also. So let's see if this one's going to work. Make your prediction. Do you think it's going to work? Let's see. This green point is at 1, comma, 1, 2, 3, 4, 5. 1, comma, 5. So that's the x, that's the y. One last time we're going to substitute. So y is greater than 2x plus 3. I'm going to substitute. My y was 5, greater than 2 times 1 plus 3. Let's go ahead and simplify it. 2 times 1 is 2, plus 3 is 5. So let's read this statement carefully, very carefully. I'm going to read it out loud to you. Listen. 5 is greater than 5. Is that really true? Is 5 greater than 5? 5 is not greater than 5. 5 is equal to 5, but it's not greater than, right? On the last one, we said 5 is greater than or equal to 5, and that was correct because it had that or equal to piece, right? That's what made this one true. But this one doesn't have that. So this one is not true. So that means that this green point right here is not a good point, but it's on the line. But it's not a good point. So what happens is there's this second rule, right? This second rule says if it is a greater than or equal to, or if it's a less than or equal to, the points on the line work, right? I'm going to write that out. The points on the line work. When I say work, I mean that the statement that reads is true, right? So the points on the line work. So this means if you have that equal to line, you draw a solid line. That's what's special about these two. So now that we know that in this situation, the points on the line didn't work, here's the other part of that rule. If you have a greater than symbol or a less than symbol, these do not have the line underneath, the points on the line do not work, right? We saw that here. This one doesn't have the equal to line. It was not true. It did not work. So when we have one of these symbols, we have to have a dotted line. So that is a very careful difference. So in this case, we had a greater than symbol. So because it was greater than, we shaded above. And because it does not have the line underneath, we need to draw a dotted line, not a solid line. So I'm actually going to go back and erase pieces of this line. It's going to be a dotted line. And a dotted line is pretty much just a dashed line. So I'm going to make it a little bit darker for you to see. A dotted line means that when you draw your line connecting these, it has spaces in it, right? It's not a solid line. If you draw a solid line on one of these, your teacher is going to mark it incorrect and you will get that question wrong. It has to be a dashed or dotted line, right? With spaces in between them. Okay, so make sure you're paying attention to those rules and what those inequalities look like. You will not always have to do test points to figure out these. Once you learn these rules and they are stuck in your brain, you will just know which points work and which points don't. Okay, so in the next couple of videos, we're just going to be working with the rules. We're not going to be substituting test points or anything like that. But if you don't understand these rules, guys, this is a for sure way that you know which points work and which points don't. Okay, so by now, I hope that you have a good introduction of what it means to graph inequalities. A lot of it was the same as equations, right? You begin with the b, you use your slope to rise and your run, all these different things. There's just these little four special rules you got to remember, okay? And if you don't remember the rules, always plug in the points to see which ones work. Okay, I hope you have a great rest of your day, guys. Thank you for spending this time with me and learning about inequalities. It will really help you, and thank you for sticking it out and staying all the way to the end. Have a great rest of your day.